Hello and welcome back. In this video, I will be talking about user-defined table function using Python. In last video, we understood what is a table function. So that the function which returns multiple rows in a table form is called a table function. We also looked at a couple of inbuilt table functions and we also created the custom functions as well. In this video, we will be creating user-defined table functions only, but using Python language. So let's get started and quickly look at that. So in this video, as you can see, I have already created some database like demo, and we have a couple of tables created, departments and employees, which I also used in past videos to understand few of the concepts of Snowflake. So I'm going to use the same tables. The columns are also same. There is a department ID, which is you kind of say that it is a foreign key for this departments, but there is no actual references, right? Now the syntax for this Python based table function is also very similar. As you can see, create or replace. This is anyways, it's a generic for any resource creation, and this is function and function name. Then you have to give inputs, whatever inputs you want to provide, like department and salary. So I will explain instead of SQL based table function, it works a little bit differently, but I will talk about that later. Okay, now as we are returning the table, again returns table, and inside the braces you have to provide whatever columns you are going to return. So you have to define them as well, like department and the total salary. So this function is for basically getting for each department what is the total salary. Okay, now the language is Python, of course, because we are creating a function based on Python, and of course you have to provide which Python version you want to use. So runtime version you have to provide, and currently Snowflake supports up from 3.8 to 3.11. Okay, and the handler. So in handler you have to provide into the string format. So the class name. So here is the class name. So now and there is a syntax very similar to any other kind of function. Double dollar, and this is the body. Now the thing is, you cannot start this body like this. You have to start from the beginning, from zero, because it can give you indentation issue. I think I have already talked about this UDF, Python based UDF in one of the video. Okay, now as we want to calculate the total salary of department, we have created this class. So there are three methods are supported in this Python based UDF. Okay, first is initialization, double underscore init double underscore. And in that function, you can define some state variables. So suppose you want to process each row, but you do not want to process partition based rows, then you do not need this init and end partition. I will talk about it quickly after some time. Okay. So suppose there are two variables we need because we want to return department and total. Okay. So whatever the department is there, I'll just assign it in the process. So process function, or you can say method, is called for each row by Snowflake itself, because Snowflake knows what is the class and process method needs to be called. Okay, now let me disable it for now. So this is yield. So for each row, once it is processed, it will return in the tuple format, and tuple is for what are the columns we have. So department, and this is the number, right? So salary. So here what it does is for each row it returns the same value, department and salary. But here there is another method called end partition, and inside the end partition we are yielding that is salary total and the department. Okay, so now let's go and see how it works. So first of all, I will show you. Let me enable this warehouse now. I'll create this function. Functions should be created. Yes. Now let's check how many employees are there first of all. So as you can see, there are 6 employees, and out of 6 employees, 1 employee is in one department and all other employees are in other departments. So they have salaries like this: 10,000, 20,000, 15,000, 30,000, 20,000, 40,000. And when we sum them, for this department it should return me 10,000, and for other department it should return me the sum of these 5 salaries. Okay, now I have joined this departments table because I want to send the name of the department, not the ID, because this table function accepts the table name. Okay, now you could have always change this function. Instead of accepting department as a string, instead of that you could have accepted department ID, and based on department ID you could have always done this method, right? And then you can always avoid this join if you do not need that. I have kept it because I just created it, and then I also wanted to showcase that if we join the table, how we can use this table function along with that. So basically, if you do not have join and if you want to directly use it, you just need to do like this: table name, comma, space, and then table. And inside the table, you have to provide the table name and whatever the input is. So what is the input? Input is the column coming from this employees. So right now it is d.name because I joined it. But if you haven't joined, you could have passed EMP ID, so department ID, right? And the salary. And over, as you can see, this is the separate syntax which was not there in SQL based table function calling. But here, if you see, this is the over, and inside after that, what you are doing is you are giving the partition by d.name. So you are partitioning this all the rows coming from employees table, and because of this table function understands, I mean Snowflake understands that when to call this end partition function. So suppose there is a department called, this is the department ID, right? 1, but it's a department, employee department. Let me see what are those department. Okay, let me see, select start from departments. Okay, I think I have to enable this warehouse again because it is disabled. And if I see the departments, there are 3 departments: engineering, marketing, and sales. So engineering is the department, right? And if I run this employees, if you see, this one is, so these are engineers and these are the marketing. Okay, now for this engineering department is all over, then end partition will be called, and for that department, engineering department, what is the salary total is already calculated by this, and that variable will be written here. So for each department this will be called. So suppose there are 2 departments found in the employees list, then this end partition function will be called twice only. Okay, so this is how it works. Now let me show you this join. So I'll remove this, and yeah, I'll bring this back. Select f.department, f.total. So what is f? F is the alias for this table. Okay, and employees is the table. We have joined the departments, and department joins by department ID, and we are taking the d.name and also partition by d.name. Okay, so this is how we call it. Now if we run this, let's see what happens. Again, this warehouse is disabled because I have made it for 1 minute. Now if you run this query, engineering is 1,25,000 or 125,000, you can say. For marketing it's 10,000. Okay, so as you can see, this is giving me like that. But if I enable this, actually I enabled it, why it did not work? Okay, so basically it gives you for this when you use this over. But if you don't use over, and if you run this, sorry, it's not, yeah, it is giving me for all partitions, sorry, all records. It doesn't call this end partition function. It calls it, but once all the rows, all the records are executed. Okay, so whatever the last record was there, that is department, and the last record was engineering for this processing, and whenever and whatever the total was that at that time. So if you remember, 125,000 records were there, sorry, 125,000 salary was there for engineering, and for marketing it was 10,000. So 10,000 is also added here. But if you provide this over partition by d.name, and if you run this way, you will always get this one. Okay, now further you can always include third-party packages as well. Suppose you want to process lot of big arrays using NumPy. So here is the additional syntax you have to add called packages, and inside that you have to pass the package name, and then you can import it as like this, similar to normal Python script, right? So you does this, and I have just modified excuse me, so I just modified it further for processing that. So now suppose you are running statistics on salaries, okay, for each department, then you can write like this. You can always use NumPy, and you can run some complex functions here, but for now, just to showcase, I have used average function. So how did I do that? So I created this another state variable called underscore salaries, okay, and this underscore salaries where I am appending each salary for that particular partition, okay. Now as you can see here, and the salaries I am using, and I am converting it to NumPy array using this np.array function, and then I am just calculating the average for that salaries. I can always use max functions, min functions, and you can find out min and max of the department, okay, and then you can pass this into this yield. And you can see here I have also updated this syntax for this table function, like I am also returning the average. Now I'll just create this function, sorry to do this, okay, and I'll run this, and I'll just copy paste, and I will run this query with different table function name, okay. Input is same, and then here I have to just write like this, average. What is the table name? Yeah, average, okay. Now if I run this, you will get the average of this department. So engineering has the average salary of 25,000 and marketing has the 10,000. So this is how you can use this Python based UDTF, okay. And whenever you have some complex logic requirement which you cannot execute in SQL, so beyond SQL capabilities, you will always have to go either Python or Java based or SQL based, JavaScript based. So wherever the packages are available for you, like whenever you have some number processing, right? So pandas is there, NumPy is there. So those kind of libraries are always useful to calculate some numbers, right? So you can use that. So yeah, that's pretty much that's how you can implement the UDTF in Python. So in next videos, I'm again coming back with a couple of more Python based functions like aggregate functions, and then vectorized UDTFs, right? So stay tuned. So thank you for watching. If you found this tutorial helpful, please like, share and subscribe for more content. Happy querying with Snowflake. See you next time.